Hi guys, welcome back. This is Professor Hank, and in this video I'm going to talk to you about synonyms in C++. Specifically, we're going to talk about the typedef keyword. We're going to talk about this tool which enables you to apply custom names to things that already exist, or names that already exist. So you already know that you can name your variables wherever you want: fat, bat, rat, cat, dat, bat, whatever, right? But you can also come up with custom names, synonyms, aliases, for things that already exist. So, for example, data types, right? So instead of creating a variable int x, right, you could, come up with a new name for int. You might say, well, I want, instead of referring to a variable as type int, I want to refer to it as type foo. And you might think to yourself, well, what's the point of that? Well, point one here, makes your code more descriptive, right? So let's say, for example, that you're writing a fantasy role-playing game, okay? And in your code, you want to have a variable that's going to represent how much health somebody has, right? And so you come up with a variable name and you say to yourself, all right, well, player one, right? So we'll have a variable named player one health. Okay, that's good, right? And so then you start thinking, well, what kind of data type do I want to have, right, to store the health? And so you think about the requirements for your game and your design and everything. And you're like, well, according to the rules of my game, I'm never going to have negative health, because once you hit 0, your character's dead. And so you might say, okay, well, all right, it's only going to be integers, because you've decided you don't want to have fractions of health. Maybe it's like a hit point system from D&D or something, right? And so you're like, okay, well, I could have 100 hit points or 99 hit points, 87 hit points, but you can never have half a hit point. So you say, okay, well, I need an integer data type. And so you could say, well, integer, they can never be negative. And so you might think, well, I'll go ahead and make it an unsigned int. And you think about it some more and you think, well, the most health anybody's ever going to have in my game is going to be, a couple hundred hit points max, maybe 1,000 or two. And so you take it even further. You're like, well, I'll go ahead and save a couple bytes of memory too. And so you say, well, let's make it an unsigned short integer. Right? That's a lot to type out in your code over and over and over again. Instead, why don't you use a typedef and create a new data type that's a synonym, an alias for unsigned short int. Call it health, right? So then instead of creating a variable, unsigned short int player one health, you could just create a variable, declare a variable health player one, right? Or health player one health. Okay, I'll show you what I mean here in a second. The code makes the code more descriptive, makes it easier to read. So you can have an abstraction where you're kind of separating the underlying data type, or the underlying implementation of that data type, definition of that data type, from its meaning, right? So I guess you could say that the semantics and the implementation kind of get separated out. And so instead of seeing a bunch of ints everywhere, now you're starting to see stuff, or unsigned short int, or double, or float, or whatever. Suddenly you're seeing type names like health, mana, speed, right? So it can make your code a lot easier to read. And it can also make it so that maintaining your code is easier. So let's say that you're writing a bunch of code, hundreds of lines of code, and you've got 27 different double variables, right, that are all related to each other in some way. Okay, and later on you determine, well, no, I don't want it to be doubles anymore for whatever reason. Maybe you're like, I need to save some data, and so you're going to change it. You need to save some memory, excuse me. So you're going to change it to floats, right? You're going to cut your memory usage in half. And so if you're going to do that, then you'd have to go and make 27 edits, wouldn't you? You'd have to change all those doubles to floats. Well, if you use a typedef, then you'll only have to make one edit. Okay, so typedefs are one of those kind of tools in the language where you don't absolutely have to use it, but in the right situation, it can be really, 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 really useful, right? So that's what we're talking about. There's a little bit of theory. There's a little bit of justification for it, why the tool's useful. Let's look at a coding example. Okay, so here we are in Visual Studio, right? And I got ourselves a project set up here. And so let's see this play out, right? So I was saying, you know, for your game, that you might have decided to do something like this, right? Unsigned short int, okay? And then you'd say, you know, player 1 health or something like that, right? Well, look at all this typing here, and it's not really all that descriptive, right? You know that it's going to be an integer, but you know it's not going to hold any negative numbers. But wouldn't it be nice to not have to type as much, or to have something that's specifying exactly what type of data is going to go in here? And in this case, what do we mean by what type of data? Well, in this case, it's health, right? This thing is going to be used to record health, right? So that's the kind of data that's going to go in there. It's more expressive. It's more accurate than just to say unsigned short integer. Right? You're adding this layer of abstraction. So what I can do is I can say, well, typedef, okay, and then I can specify what I'm making a synonym or an alias for, and then I can make the alias, okay? So now, instead of typing out all of this stuff, right, this is still there. I mean, it's still in the language. It's still a primitive in C++. But instead, I could just do something like this. Health player 2 health. Right? So this now is a synonym, an alias for this. Right? So I could come up with a whole bunch of these, right? So what if I also had magic in my game, right? I had mana or something. I could say, well, typedef, and it doesn't make any sense to have negative amounts of mana maybe in my game, so I could say, well, unsigned short int mana, right? And so then I can come down here and I can say mana pool, right? So now this is creating a variable of type unsigned short int, but I only have to write mana now, okay? And so looking at the variables themselves suddenly becomes a lot more descriptive. Well, this is a pool that's holding mana. Well, what's mana? Well, it's whatever I defined in my game to be, right? But that is a lot easier to read, a lot more, I don't know, maybe it makes a little bit more sense than to say, well, unsigned short int. No, this is for mana. This variable is holding mana. You see what I'm saying? So you've taken the semantics away from the data type. You've kind of changed the meaning of what's going on here, even though the representation, the underlying representation, you know, the internal implementation is still unsigned short int. But now this is fits more within your theme, I guess you could say, right? It's more expressive. I know that this variable is for holding mana, right? I know that this variable is for holding the health, or, you know, whatever the health represents within the game. Okay, so you've got that, but also, let me give you another example of making your code more readable, right? So let's say that I had, a function prototype that looked like this, right? So fine, I mean, you could create a function that returns an int that's named X. It's horrible because it's not very readable at all. You know, the reader of the code is left wondering, well, what the heck does this thing do? Right? They'd have to go and look at the code definition, or the definition for the function, to actually figure out what the heck's going on. It's a terrible way to name your function, right? But let's say that you had something like this instead, where you maybe named the function replenish, or maybe even fill, right? Yeah, I'll go with replenish. Okay, and then for your return type, you make it mana, right? So now you've got this function that is, or this prototype, I should say, that's for a function that's named replenish, and so you know that this thing's going to be replenishing. And what's it replenishing? Mana, right? So this thing's going to return mana. So, you know, it gives you a whole bunch of different options here to make your code easier to read, right? And easier to read code's always good. You know, let me give you another example. Right? So let's say you wanted to you had to represent weapons in your game, right? And so you might have integers that represent their codes that correspond to a database or something, or there's a row in your database. And so that row in the database has ID numbers that represent the type of weapon. Maybe that weapon has, damage, attack speed, length, whatever, weight. Okay, well, you might need to have an array that represents the weapons that your particular character can hold, right? So you could say something like this: weapon, hands, 2, right? So now you're saying, okay, well, this is a array that's representing what my character is currently holding, right? Or another example, I'm beating this to death now, aren't I? But you can say equipment. Similar kind of idea. But now you can say, well, let's create a array that represents, a backpack, right? So this is my equipment array. So this array represents a backpack, and it now can store, 10 items. What are the items that it stores? Well, this is a backpack. This thing holds equipment, right? Or type money, right? And then you have a variable purse, right? So it can make your code a lot easier to read. So that's number one. Number two is you can make your code easier to maintain, right? So let's say that you create another data type, typedef, and for whatever reason you've decided that you need an alias for the primitive double, and I don't know, you name it whatever. Name it foo. For this example, it doesn't matter, right? But so you have in your code all over the place a bunch of foo variables, right? Maybe you even have an array of foos, whatever, right? So you've got just all this stuff all over the place for whatever reason, okay? And later on, you're like, oh, well, you know what? Actually, as it turns out, after some thinking about it, I don't need an 8-byte floating point data type for this. I could cut my memory usage in half if I went with floats, because the range of numbers that I'm going to store, is always going to fall within that need of 4 bytes, right? A float can store the numbers just fine. So if that's the case, then you can just make one edit like I just did a couple times, right? You can just say, well, let's change this typedef from a double to a float, right? And so by doing that, I've changed all of these variables now so that they're not 8-point floating, or they're not 8-byte floating point data types. They're now 4-byte, right? Just by making one change. If I had hard-coded in double for all these things instead of my typedef there, then I would have had to have made an edit for every single double for these variables, right? And what if I make a mistake? What if there's some variables that were doubles that I want to change, but some that were doubles that I wanted to leave alone? Well, I might change the wrong variables by mistake, right? But if I use a typedef for that, then there's no possibility of that happening, because I just go up to my definition and make the change there, and then it automatically changes all the foos, right, in one go. So easier to maintain, less chance of you making a mistake when you go to update your code. One more thing here that I'll show you, and then we'll wrap it up. In C++, it's really nice because when we're talking about defining structs, and when we define a struct in C++, we could just use the keyword struct. We have the tag for the structure, and we're done, right? And once we've done that, we can create a variable and just call it bar b, right? Now in C, right, this isn't the case, right? In C language, you have to include that struct keyword with the data type. Right? So C++, we don't have to do that. I still see that in my classes. Students do that, I guess. I don't know where they picked that up from. But they do it, and I'm like, I always leave a little note. Not necessary in C++. You can leave it out. But in C, you can't, right? So what you can do is you can use a typedef, and this is a common thing. You can use a typedef to get rid of that, right? So you can do something like this, create your struct, and from there you can come up with your name, whatever you want to do, and then instead of saying struct bar every single time, you could just do dog, right? So that way you don't have to type out that struct anymore, that's keyword. So it can save a little bit of typing, and that's a thing that a lot of C programmers like to do from time to time. Okay, so yeah, I mean, that's everything that I wanted to show you in the video. Typedefs, if you've never heard of them before, you got along fine without them up to this point. But just like so many different features in a language, there's a lot of tools there that can make your life maybe a little bit easier, can make your code a little bit more readable. Maybe you can think of them even as kind of quality of life things. I mean, you don't have to have typedefs to write code to do stuff, but they're there in your toolkit and you can use them, and they do have a purpose. So now that you know about it, you might find it useful, you might not, right? When do you use it? When you feel like you need to. So there you go. Way to make your code a bit more readable, a bit more maintainable, and in the case of C, a bit easier. And well, I guess you could say in the case of unsigned short int, less typing, right? A lot less typing in certain situations. Anyway, okay, all right. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.